Imagine the universe as a giant highway, but instead of cars, we have galaxies, each one a massive collection of stars, planets, gas, and dust, all bound together by gravity. These galaxies are like the vehicles on this cosmic highway, constantly moving and interacting with one another. Instead of cars, we have galaxies. These galaxies are always on the move, zooming through space at incredible speeds. Some of them are spiral-shaped with beautiful winding arms, while others are elliptical, more like stretched-out spheres. Each type of galaxy has its own unique characteristics and behaviors. These galaxies are always on the move, zooming through space at incredible speeds. They can travel at hundreds of kilometers per second, covering vast distances over millions of years. This movement is driven by the gravitational pull of other galaxies and the mysterious dark matter that makes up most of the universe's mass. Like cars on a busy road, sometimes these galaxies collide. When two galaxies come close enough, their mutual gravitational attraction can pull them together, leading to a cosmic collision. These events are incredibly rare on human timescales, but are quite common over the billions of years of the universe's history. These collisions are the biggest events in the universe, and they can completely reshape galaxies. When galaxies collide, their stars, gas, and dust interact in complex ways, often leading to the formation of new stars. The gravitational forces at play can distort the shapes of the galaxies, creating stunning visual phenomena. These cosmic crashes aren't like car crashes. They don't happen in an instant. Instead, they unfold over incredibly long periods of time. The process of two galaxies merging can take hundreds of millions or even billions of years to complete. They happen over millions of years. During this time, the galaxy's shapes change dramatically. Spiral arms can be stretched and twisted, and new structures can form. The end result is often a single, larger galaxy, sometimes with a completely different appearance from the original galaxies. But even though they're slow, they're incredibly powerful. The energy released during these collisions is immense, and the effects can be seen across vast distances. The merging process can trigger the formation of new stars and even new planetary systems. They trigger shock waves, ignite starbursts, and even awaken sleeping black holes at the hearts of galaxies. These black holes, which can be millions or even billions of times the mass of our Sun, can become active, consuming nearby material and emitting powerful jets of energy. The universe is a dynamic and ever-changing place, with galaxies constantly on the move, colliding, and evolving. Astronomers recently spotted a galaxy on a crash course. This galactic speedster was traveling at a mind-blowing 2 million miles per hour. It slammed into a group of galaxies, creating a cosmic spectacle. The impact sent shockwaves through the surrounding gas and dust. These shockwaves triggered the birth of countless new stars. Imagine fireworks on a cosmic scale. One group of galaxies, called Stephan's Quintet, has been putting on a show for billions of years. This mesmerizing cluster of galaxies is a testament to the dynamic and ever-changing nature of our universe. Imagine the vastness of space and the incredible forces at play as these galaxies interact with one another. It's a cosmic ballet that has been unfolding for eons, captivating astronomers and stargazers alike. Discovered back in 1877, this group of 5 galaxies is located in the constellation Pegasus. The discovery was made by the French astronomer Édouard Stephan, who first observed this fascinating cluster through a telescope. Since then, Stephan's Quintet has been a subject of intense study and observation, revealing more about the complex interactions and behaviors of galaxies. The constellation Pegasus, where this quintet resides, is a prominent feature in the night sky, easily recognizable by its distinctive shape. 4 of these galaxies are locked in a gravitational dance, constantly interacting with each other. This gravitational interplay causes the galaxies to distort and stretch, creating fascinating shapes and structures. The interactions are so intense that they can trigger bursts of star formation, as clouds of gas and dust are compressed and heated. These new stars add to the brilliance and complexity of the quintet, making it a living laboratory for studying galactic evolution. As these galaxies move around each other, their gravity pulls out streams of gas and dust. These streams can stretch for thousands of light years, connecting the galaxies in a delicate web of material. The gravitational forces at work are immense, shaping the galaxies and their surroundings in ways that are both beautiful and scientifically intriguing. Observing these streams helps astronomers understand the processes that govern galaxy formation and interaction. These streams, called tidal tails, create beautiful swirling patterns in space. Tidal tails are formed when galaxies pass close to each other, their gravitational forces pulling out long, trailing arms of stars, gas, and dust. These tails can be sites of intense star formation, as the material within them collapses to form new stars. The patterns they create are not only visually stunning, but also provide valuable clues about the history and future of the galaxies involved. Stephan's Quintet, with its intricate dance and stunning tidal tails, continues to be a source of wonder and discovery in the field of astronomy. In the heart of Stephan's Quintet, a massive shockwave is rippling outward. This shockwave, created by the collision of two galaxies, is heating up the surrounding gas to millions of degrees. This intense heat is triggering the formation of new stars at an incredible rate. It's a cosmic nursery where stars are being born before our very eyes. Section 5. Cosmic Detectives: Unraveling the Secrets of Galaxy Collisions. To study these distant cosmic events, astronomers use incredible telescopes. One such telescope is the WEAVE spectrograph. It allows astronomers to measure the speed and composition of stars and gas in galaxies. Another powerful tool is the LOFAR radio telescope. It's like a giant ear, listening to the faint radio waves emitted by galaxies billions of light-years away. Section 6. The Universe's Grand Recycling Program: Why Galaxy Collisions Matter. Studying galaxy collisions isn't just about pretty pictures. While the visual spectacle of galaxies merging is indeed breathtaking, the scientific implications are even more profound. When two galaxies collide, they don't just pass through each other like ghosts. Instead, their gravitational forces interact in complex ways, leading to a cascade of cosmic events. It helps us understand how the universe works. By observing these collisions, astronomers can gather data on the behavior of dark matter, the mysterious substance that makes up most of the universe's mass. These interactions also provide insights into the distribution of stars and gas within galaxies, revealing the hidden dynamics that govern their evolution. These collisions play a crucial role in the universe's evolution. Over billions of years, galaxies grow and change through these interactions. The Milky Way, our own galaxy, is on a collision course with the Andromeda galaxy, and in about 4.5 billion years, they will merge to form a new galaxy. This process will reshape the structure of both galaxies, creating new star systems and potentially altering the fate of existing ones. They can trigger the formation of new stars. When galaxies collide, the gas and dust within them are compressed, leading to bursts of star formation. These starburst regions are some of the most active and dynamic areas in the universe, where new stars are born at an accelerated rate. This process enriches the interstellar medium with heavy elements which are essential for the formation of planets and, ultimately, life, and even grow supermassive black holes at the centers of galaxies. The intense gravitational forces at play during a collision can funnel gas and dust into the central regions of galaxies, feeding and growing the supermassive black holes that reside there. These black holes can become active galactic nuclei, emitting powerful jets of energy and influencing the evolution of their host galaxies. It's like the universe's grand recycling program. The cosmic dance of galaxies merging and colliding is a fundamental part of the life cycle of the universe. Old stars and gas clouds are recycled into new generations of stars and planets, ensuring the continuous renewal of the cosmos. Gas and dust, thrown out from colliding galaxies, will eventually come together to form new galaxies. This process of galactic recycling ensures that the universe remains dynamic and ever-changing. Each collision is a step in the ongoing story of cosmic evolution, contributing to the rich tapestry of the universe we observe today. Section 7. Cosmic Ballet: When Galaxies Collide. Our own galaxy, the Milky Way, is on a collision course with the Andromeda galaxy. Don't worry though, this cosmic collision won't happen for another 4 billion years. When galaxies collide, they don't just crash and burn, they can merge and create new, larger galaxies. These mergers can create stunning features like tidal tails, rings of stars, and even new spiral arms. Section 8. Safe Haven Earth: No Cosmic Fender Bender for Us. Even though galaxy collisions are incredibly powerful, Earth is safe from these cosmic fender benders. The distances between stars within galaxies are so vast that our solar system is unlikely to be directly affected by a galaxy collision, so we can relax and enjoy the cosmic show from a safe distance. Section 9. The Universe. An endless frontier of discovery. The universe is full of mysteries waiting to be unraveled. Every time we look deeper into space, we discover something new and amazing. Galaxy collisions are just one example of the incredible events that shape our universe. As we continue to explore the cosmos, we're sure to make even more exciting discoveries.